Hi, so welcome to the tutorial for loading map and planning around it. So moveit is really powerful, but in order for it to be useful, we need to be able to load a 3D map in moveit and use that to plan a trajectory that we can actually follow. Now, moveit actually provides a service call for loading the map, but for some reason that's not working. I should have to figure out why, but I found a workaround, which is use a bag file. As in, when I'm taking, when I'm recording, when I'm basically using a point cloud to generate a map, or I'm taking point cloud of an area, I record all those point cloud data and I record the transforms from it, and I store it into a bag file. Now, once I've stored it into that bag file, I can then later play it and then use that simulated information to create my world. So let's go step by step. What all do we need to do for that? Okay, first we go into airtone config. We need to create this sensor points.yml. The details are there in the wiki, you can look it up. So we need to create this sensor points.yml. Now this basically tells moveit which plugin to use and what is the point cloud topic. So this is important. This is from where I'll be reading, and all of these things you don't need to really edit. And then we have to go and launch. We have to set up one more thing, set up sensor manager. In this you just need to add these two lines wherein you specify where is the config file for the sensors and what is the base frame that we'll be using. For here we'll be using ODOM, right? Once that is done, you can go into our package, and over there you should be able to find the launch file which says for simulated map. Now in this for simulated map you have basically a lot of features. Let's go through them one by one. So this is basically necessary to since you're playing back a RAW's bag file, you need to use simulated time, otherwise it'll assume the true time, which is obviously wrong because you recorded it way back. Now this is just an argument, so when you want to take arguments in the launch file, you use this, and config package is just an argument which I'm again and again using to give the package name that I'm using. So over there you'll have to give the exact link, or just give it a find in the command line if you want to change this, or just change it over here. This is basically the package name of the setup that we had created. This is debug true or false. Over here we basically loading the entire planning context. This is where the planning and everything happens. We are basically playing the RAW's bag here. Okay, so we have created RAW's bag. It has been provided to you. You can just edit this path to your particular bag file, and this is the bag file that we'll be using. This is a bag file of the simulated world that we had created. These are some static transforms that we have created for. So there are some transforms that we need because somewhere the world frame is ODOM, somewhere the world frame is world, somewhere it is base, somewhere it's called something else, somewhere it's called something else. So we need to map what is what in different packages. So this is just to map all of that. Then this is a joint state publisher. This basically publishes the state of each joint with respect to the others, and this is the robot state publisher, which basically publishes the state of the robot. If you'll be working in ROS, you would have come across these two very often. Then we start a move group, which is basically the functionality of moveit. This is wherein everything happens, the planning, the navigation and everything. And then we launch RViz with its particular launch, which has its own config and everything. You can look into all of that. It's all in the package. If you want to dive deep, you can go through the moveit's official website and you'll get to know all the information. It's pretty well documented. Alright, so let's start this up. Again, very simple startup. All you need to do is ROS launch drone application for simulated map. Start. We'll wait for it to load. Still loading. If your processor is really bad, this might take a long time. So as you can see, if you remember in our simulator videos, we had such a kind of an environment wherein there was a big wall in front and a small wall towards the left. So now it's done. So the entire map has been created. Now we can plan around it. So let's create a plan. All right. So let's take this behind this. All right, and let's go to planning and plan. Something failed. No motion plan found. Oh, I'm sorry. We need to edit this. We need to give it enough workspace to be able to make any plans. The workspace is very small. Once you've done that and we plan, it is able to create a trajectory from here to the goal. Now whether it's an optimal trajectory is another question. You can experiment with some of these algorithms given, but on a general note, trajectories for quad rotors are not planned in this way. They're generally planned by minimizing snap. This is just minimizing the distance. And if you want to read more, I'll provide a link in the description where you can get more information on how to plan trajectories specific to a drone. Well, that's it for this tutorial. Next time we'll see how to extract these trajectories and then move using it.